video will be over textbook pages numbers 8 through 11. For this problem, we're going to simplify 3 squared times 4 squared raised to the 5th power. To start this problem, we start by distributing, that means multiplying the 5 by both numbers inside the parentheses, which means our problem changes from 3 squared to 3 to the 10th, 2 times 5. We also do it with 4 squared. We change it to 4 to the 10th, again 2 times 5. Now, when we have a problem that has different base numbers, 3 and 4, but the same exponent, 10, we multiply the bases, 3 times 4 to give us 12, and the exponent 10 stays the same. The next problem says simplify 9 to the negative 8th power times 1 over 9 to the 3rd power, and to write your answer with a positive exponent. To start this problem, we're going to rewrite 9 to the negative 8th as a fraction. When we write negative exponents as a fraction, the base number goes into the denominator, that's the bottom. The negative exponent, 8, changes to a positive 8, and the 1 gets left in the numerator, that's on top. We still have the 1 over 9 to the 3rd power because we have not used that part of the problem yet. Now we are multiplying, and so when we are multiplying, we add our exponents. Our exponents being 8 and 3 added together give us 11, and the 1 stays on top. 1 over 9 to the 11th power is our answer. For this next problem, it says which expression is equivalent to 45 to the negative 3rd divided by 45 to the 3rd. Since we are dividing, we would subtract those exponents, negative 3 minus 3, which would give us an answer of negative 6, meaning our answer would be 45 as our base number and a negative 6 for our exponent. However, all negative exponents must be written as fractions, meaning the 45 base number goes in the denominator on the bottom, and the negative 6 changes to a positive 6 with a 1 left in the numerator. Our correct answer is letter C, 1 over 45 to the 6th power. It says Isaac chose A as the correct answer. How did he get that answer? So in order to get a negative 1 for your exponent, Isaac divided the original exponents. Isaac did negative 3 divided by 3 to get a negative 1. So we can go ahead and write that statement. Isaac divided the exponents to get 45 to the negative 1st power. He should have subtracted the exponents. To get 45 to the negative 6th. For this problem, it says which expression is equivalent to negative 4 raised to the negative 5th power raised to the 0 power. When we're raising to a power, we start by multiplying the exponents, so negative 5 times 0 would give us 0. So our new problem is negative 4 to the 0 power, and we know that anything to the 0 power is equal to 1. Letter A is our correct answer. For this next problem, which expression is equivalent to 7 squared raised to the 5th divided by 7 to the negative 6th? We start by multiplying our exponents, 2 times 5 to give us 10, and then we rewrite the problem. 7 to the 10th power is now on top, 7 to the negative 6th is now on the bottom. Now we have a simple division problem in which we would subtract the exponents, so 10 minus negative 6. When we're subtracting negatives, we would keep, change, change. So we keep the 10, change subtraction to addition, change the negative 6 to a positive 6 to get an answer of 16. 7 to the 16th power is our correct answer, letter D. For this problem, it asks which expression is equivalent to 1 over 49. Select all that apply. This select all that apply means that there is more than one answer. So we need to look at each answer choice and decide if it is correct or not. For the first problem, we are multiplying, so we're going to add the exponents, -1 plus -1, which would give us a -2. Our new problem is now 7 to the -2nd power. Negative exponents must get written as a fraction, so that becomes 1 over 7 squared. 7 squared is really 7 times 7, which is equal to 1 over 49. A is a correct answer. For letter B, we start by adding the exponents, 8 plus -6, which gives us a +2. And so our answer becomes 7 to the +2nd power, which is 7 times 7, which is a +49. It is not written as a fraction because it is a non-negative exponent, so B is not a correct answer. For letter C, we start by adding the exponents. -5 plus 3 gives us a -2. Our answer is 7 to the -2nd power, which we then write as a fraction, 1 over 7 squared. We break it down into 1 over 7 times 7, which gives us an answer of a fraction, 1 over 49. C is a correct answer. For letter D, we start by adding the exponents, 7 plus -9, which gives us an answer of -2. Our new problem is 7 to the -2nd power, which we need to write as a fraction. We break it down into 1 over 7 times 7, which gives us the fraction 1 over 49. D is also a correct answer. And the last option, E, we have -2 and 4 that we're going to add together. -2 plus 4 gives us a +2, so 7 squared does not need to be written as a fraction. It can just stay 7 times 7, which is the whole number 49, so E is not a correct answer. For this problem, we want to write 16 to the 8th power with a base of 4. So we're going to take our 16 and we're going to write it out 8 times. We are then going to break down each 16 into 4 times 4, because 4 times 4 is 16. So break down each piece into 4s. We're breaking it down into 4s because that is the number requested by the problem. Once we have broken down each piece into 4s, we can then total them up, and we get 4 to the 16th power. For this last set of problems, we're going to look at the equations below and choose true or false for each statement. For letter A, the base numbers 2 and 3 are different, but the exponents 4 are the same. To solve this, we would multiply 2 times 3 to get 6, and the exponent would stay the same. 6 to the 4th should be the correct answer, so that statement is false. In letter B, we are subtracting the exponents, 2 minus 3, which would give us a -1. So our answer would be 5 to the -1st power, which we would then write as a fraction as 1 over 5. That statement is true, even though the exponent 1 is not written. That is still a true statement. 1 over 5 is the same as 1 over 5 with an exponent of 1. For letter C, we are raising to a power, so we're going to multiply our exponents 3 times 4 to get 12, meaning our problem is actually 6 to the 12th power. We do the same thing with the other side. 4 times 3 is also 12, meaning that they match 6 to the 12th power. Letter C is true. For letter D, we are dividing, so we start by subtracting our exponents, 2 minus 7 to get a -5. So we're looking for 3 to the negative 5th power. On the other side, we're multiplying, so we're going to add our exponents to plus negative 7, which also gets us an answer of negative 5. Both exponents are the same, negative 5, with our base number 3, so that is also a true statement. Letter E, we are dividing, so we subtract 0 minus negative 4. When we're subtracting negatives, we keep change, so that changes to addition and that changes to a positive 4, meaning our answer is 8 to the positive 4th power. So that statement is false. And the last problem is a division problem, so that means we are going to subtract 10 minus 5, which gives us 5. Our answer should be 4 to the 5th power, not 4 to the 2nd power. That statement is false. We are not going to do the last problem of the textbook page as it does not concern with this set of exponent skills.